afternoon to everyone present here. We are here to present our mini project titled Total Harmonic Distortion Analysis of a CMOS Switched Capacitor Integrator. Our team members are Yashwardhan, Chanchal, and Ayush. In this project, we have designed a switched capacitor integrator in 180 nanometer CMOS technology, implemented it using Cadence Virtuoso, and then analyzed how its harmonic distortion varies with frequency. This helped us understand its filtering capability and real world performance limitations. The main goal was to verify whether the integrator behaves as a low pass filter or not. Switched capacitor circuits are extremely important in modern mixed signal VLSI systems. These circuits are commonly used in analog to digital converters, filters, modulators, and many communication systems. Rather than relying on precision resistors, switched capacitor circuits use capacitor and clocked switches to process signals in the discrete time domain. This provides very high accuracy since capacitor ratios can be controlled well, excellent area efficiency, better integration with digital CMOS technology, high immunity to component variations compared to continuous time analog circuits. Our design is based on a standard switched capacitor integrator architecture consisting of high gain CMOS operational amplifier which ensures accurate settling within each clock period, sampling and feedback capacitors that define the integration function, MOS switches that operate based on non-overlapping clock phases. We implemented and simulated this design using Cadence Virtuoso, which is an industry-grade IC tool. The technology used is 180 nanometer CMOS because it offers a good balance between analog performance, cost, and process maturity. Once we verified correct functionality, we moved forward to frequency domain analysis for THD measurement. Now the further presentation will be carried out by Ayush Samanta.
Simulation methodology, time domain to frequency domain. For the simulation methodology, we started by applying a large signal single tone sinusoidal input to our CMOS switched capacitor integrator. This helps test how the circuit behaves under real working conditions. We then perform a transient analysis using Cadence Virtuoso to observe the circuit's output over several clock cycles until it reached a steady state. After obtaining the steady state waveform, we used a fast Fourier transform to convert the signal from the time domain to the frequency domain. This allowed us to clearly identify the main signal and all its harmonics. Finally, the total harmonic distortion was calculated directly from the FFT data to evaluate how much distortion occurred in the circuit. This step was essential to link our time domain simulation results with their actual frequency domain performance. Next slide. Low and high frequency result and the TDS versus frequency relationship. When analyzing the results, we observe that all the at low frequencies such as 10 Hz and 100 Hz, the output showed discrete ripples due to sampling effect, but the integration was proper and accurate as confirmed by transient and DFT plots. As the frequency increased to 100 kHz and 500 kHz, the output became much smoother and the ripple effect was greatly reduced, showing improved integration accuracy. However, when we plotted the total harmonic distortion versus frequency, we noticed that THD remained very low at low frequencies, indicating excellent performance. But as the input frequency approached the circuit's bandwidth limit, THD began to rise. This increase in distortion mainly occurred due to incomplete op-amp settling and switch parasitic effects. Overall, this result shows that the circuit performs efficiently within its operating range, but experiences distortion at higher frequencies, which defines its performance limits. Now, the first presentation would be given by Chanchal Babdane. Thank you.
Key result THD versus frequency relationship. The slide highlights the key performance result of our design, the variation of total harmonic distortion or THD with frequency. At low frequency, the circuit performs almost ideally, showing excellent harmonic performance and very low THD. However, as the input frequency increases, especially near the circuit's bandwidth limit, we start observing performance degradation. This increase in THD happens because of incomplete op-amp settling and parasitic effect. Overall, this behavior clearly demonstrates that switched capacitor integrators behave as low-pass filter, maintaining signaling integrity in the low frequency range. Next slide. Conclusion. In conclusion, our CMOS-based switch capacitor integrator design successfully achieves stable operation with very low distortion. The observed frequency dependent THD relationship validates the low pass filtering nature of the credit, while the design performs efficiently across low and mid frequency ranges. Its high frequency performance is limited by op-amp settling and switching parasitics. This confirms the importance of optimizing op-amp dynamics to further improve overall linearity and distortion performance. Next slide. Acknowledgement. We would like to express our heartfelt thanks to the faculty and laboratory staff of Vidyalankar Institute of Technology for their continued support and for providing the simulation resources needed for this project. We are especially grateful to Professor Akhil Masurkar for his expert guidance and valuable suggestions throughout the research. Thank you.